Alright, today we're going to focus on how to solve exponential equations. So that's this one right here. Tomorrow we'll be doing writing the exponential equation. So let's just take a quick look over in the second box. What is the difference between these two equations? Well, if you notice, here, what is the base? The base is the variable. But on the other side, over here, the base is the number and the exponent is the variable. Okay, so the power equation is when the base is the variable, and your exponential equation is when your exponent is the variable. Okay, so just to make sure that those are clear. Really quick brain teaser. What does x have to be in this situation? If the bases are the same, we can just compare the exponents, right? So what are the exponents? What's the x going to have to be? It's going to have to be 4, right? Okay, so alright, so here, this is kind of the same thing. Notice that we have the same bases. That means that we can just compare the exponents as long as the bases are the same. So I'm just going to set these exponents equal to each other. Alright, and then I'm going to solve for x just to find out what x is. So I'm going to add x over, so I'm going to have 3 minus x equals 0. Then I'm subtract 3, and you're going to get x equals 3, right? Pretty easy. Now, do we know what E is? Some of us might, some of us do not. It doesn't really matter. All we need to know right now is, oh, look, our bases are the same. They're both E. As long as our bases are the same, you're going to set these equal to each other. So we're going to get, I'm going to subtract x over and subtract 8. So x is going to equal -7. All right? Now, over here, if you notice, these bases are not the same. But remember, we know how to change the base, right? 64 is actually 4 cubed. So I'm going to rewrite this. I'm going to keep that left side the same. And we want to change it so that it has the same base. Well, 64 is, like I just said, 4 cubed. So now the bases are the same. So now I can set the exponents equal to each other. So x is actually equal to -3/2. Same thing over here. Now actually this one's a little bit tricky because how do we change 1 to have a base of 4? But maybe some of us remember that anytime you have anything to the 0th power, it always equals 1. What's 4 to the 0th power? 1, right? So we've now changed 1 to have a base of 4. And if we keep that left side the same, oh look, our bases are the same, we can now just set our exponents equal to each other. So we get, add 2, x equals 2/3. Alright, and same thing over here now. This one has a little operation on the left. On the left, if we are multiplying two things, what do we do with the exponents? We add them. So we're going to actually add all of these exponents together, right? And on the right side, we want to make sure that that base is 6. 36 is 6 to the what? Second power, right? So we actually have 6, 2x plus 4 equals 6 squared. Bases are the same. I can just set the exponents equal to each other. So you're going to get -2, x equals -1. Alright, so we have 2 to the x and 1 to the 32nd. Alright, well, I'm going to start out just rewriting. I'm just going to start out by rewriting my left side. And then my right side. So 1 over 32. Well, it's going to be 1 over 2 to the 32. 2, 4, 8, 16, 32. 5, 2 to the 5th. Well, that still doesn't look exactly the same. I wish that 2 to the 5th on the right side was in the numerator, but how can we change something if it's in the denominator? How can I change it to be in the numerator? That's right, make the exponent negative. There we go. 1 over 2 to the 5th is the same thing as 2 to the negative 5th. Bases are the same, set it equal to each other, and you get x equals negative 5. All right, over here, so now I have 1/2 to the xth power. So I'm just going to rewrite this as 1 over 2 to the xth power. I could write 1 to the xth power over 2 to the xth power, but what's 1 to the anything? It's just 1, so I'm not going to write that. Okay, times 32 is actually 2 to the, we just said 5th power, right? Equals 1 over, what's 16? 2 to the 4th. Let's get everything in the numerator right now. So everything in the numerator. So this, on the very left, the first term on my left side, remember if we want to change what side it's on, we can make the exponent negative times 2 to the 5th. Same thing on the right side. If we want to change what side it's on, if it's on the bottom, we want to change it to the top. If it's on the denominator, we want to change it to the numerator. You change, make sure that exponent is negative. All right. So remember, when we are multiplying, we are going to be adding the exponents. So you're going to do negative x plus 5 equals 2 to the negative 4th. All right, do I have two things with the same bases? Yes, I do. So I'm going to set those exponents equal to each other. Negative x equals negative 9, x equals 9. All right, let's keep simplifying this third one. If you guys actually, why don't you pause it, try to do this third one. If you need help, you can play the video, but try to do this on your own first. Okay, so on this third one, what do we do when things are being divided? What do we do with those exponents? If you said subtract them, you are right. So we're actually going to have 2, keep the base the same, subtract the exponents. Okay, and we want that 32, we want that to have a base of 2. We already know that's 2 to the 5th. All right, let's simplify that exponent in the top left there. So 2x minus x, we're going to get x minus 3 equals 2 to the 5th. Set those exponents equal to each other. As long as they have the same base, x is going to be 8. All right, and that's it. Good luck on your homework.